Okay, so now we've done the installation of the new Ox Ozone system, we're going to have a look at how we actually calibrate that module. While we do it, we'll also have a go at calibrating the CO and SO2. This is going to be an introduction to the calibration interface. There's a few details around how to calibrate the Ox Ozone system as a pair, which we need to cover off. And we're also going to have a little bit of a look at how to calibrate CO. The video will have a look at the gas connections. We'll briefly cover how to operate the Cal 1000. But the key focus is going to be on the calibration interface in the software. So let's get stuck in.
Okay, all of the content which we're going to cover in this video is also found in the AQS1 and also in the AQM65 user guide in the calibration section. So please make sure that you also familiarize yourself with the contents of the user guide, whether it's the AQM65 or whether it's the AQS1. This particular video demonstrates calibration using external calibration systems like the 2B Tech or the Cal 1000. If you have an Cal 8000 shown here in this video, you can still follow along. There'll just be a few subtle differences in the software. Okay, so the first thing you should do is turn on your ozone calibration source and allow it to warm up. It can take anywhere from about 10 to 12 minutes to warm up. After the ozone calibration source has warmed up, we recommend that you set the ozone calibration point to your chosen ozone calibration point. We won't be delivering ozone straight away, but it can take some time for the ozone calibration source to stabilize. So it's a good idea to get it going and delivering ozone while we start with the zero calibration. You can just use the adjustment knob on the front to set the concentration. So here I'm setting the concentration to 100 ppb or 0.1 ppm. So just leave that going. On the back of your Cal 1000, you should have it plugged into a power source. Make sure that you insert the zero air inlet correctly. This filter will protect the pump. And we recommend that you leave the pump override switch in the on position if you have one of these switches on your Cal 1000. The mass flow meter reading on the front panel of your Cal 1000 should be about 2500 or 2600. And it's really important that when you complete the connection to the inlet, that you have an open T, so that the excess calibration gas can escape. This is really important whether you're using an Cal 1000 or an AQS1 as shown in this picture. Okay, so let's move over to the software. We'll be working in the Calibration and Service app. This is a fairly recent upgrade to our calibration screen, so some of you may not have seen this before. On the left-hand panel, we can see a list of all of our gas modules which were installed, and we can see a small line plot showing the response of that gas module over time. Over on the right side, we can see a more detailed version of the CO module in this case. You can also see that we have access to the gain and the offset for the CO module, and of course we'll have access to gains and offsets for everything else. The offset and the gain that you see in the new calibration screen is the same as it is here, the same as it was in the previous manual entry screen. But we'll be working primarily in this new calibration screen today. So you can see that you can have access to offsets and gains for the new Ox module. You can change the offset and gain in the screen. You can also see the current reading and the average reading and the standard deviation, just as you would have seen it previously in the manual entry screen. So we'll be focusing most of our attention on how to use this information to facilitate our calibration. Before we start, it's a really good idea to enter into manual service mode. All this does is it tags the data as being service data. You can see here there are 2 lines of data which have been tagged as service data. This helps us later on when we come to do our data analysis. It helps us to filter out any data which was captured as part of the calibration. So it's a really good idea just to push that manual service button. So the software is telling us that the service is in progress. If we don't stop it, it'll time out in 24 hours, so that's fine. We go back into our calibration screen now, and after a few minutes time, you should start to see that all of the data in the table on that right-hand side will start to be highlighted in green. This tells us that the data is tagged as service data, which means it's very easy for us to filter it out later on when we come to do our daily averages or hourly averages. Here we go. So we're back. All of the data now has been tagged as service data, which is great. Now we're interested in continuing on with the zero calibration. And first of all, we're going to check to see that the modules are stable, which they are. We can now click recommend, which will recommend us a new offset based upon the recommended offset formula, which you can also find in your user guide. If we're happy with the recommended offset, we can click apply. Are you sure you want to apply? Yes. And now we can see that the current offset has now been recalculated. Previously, this would have been done manually with a calculator or with Excel. Now we can use the recommend button, which makes things a lot easier for us. Okay, so we just need to wait for a few minutes and we can see the impact that that offset adjustment has made on the CO data. Okay, here we are. The graph in the top right hand corner has illustrated the impact the offset adjustment has been made. We can see now that the readings for CO have come right down to 0 and the offset has been annotated in the very top right hand corner of the graph. We can switch across now to the Ox module. We can apply exactly the same process to the Ox module. First question is the Ox module stable within the requirements for stability? Which it is. You can see the standard deviation for the Ox is very, very low. The average reading is slightly negative, so it looks like we will be needing to apply an offset on the Ox, but the standard deviation is just 1 part per billion, so that tells us that it's stable and ready to be zero calibrated. So let's push the recommend button. We recommended a new offset of 0.001. Again, it's just the same formula that's been used. Are you sure you want to apply it? Yes, I'm sure. Now the new offset has been applied to the Ox module. So I won't show you the process for all of the other gases. It's exactly the same procedure. I'll leave that up to you guys to do. Let's head on over to the manual entry screen, a screen you may be familiar with. And you can see now that the average readings for each one of those gases on that top line there are all within the acceptable range. Notice that we have not changed the offset on the NO2 channel. That's really important. So now let's have a quick look at our gas regulators, because we're now about to deliver NO2 gas. The regulators, Aeroqual supplies those. You can order that directly from us. It's a 2-stage pressure regulator. The top stage maximum is only 15 psi, so that's more than enough for the Aircal 1000. Just a quick refresher on the gas cylinders. There's a really comprehensive list of gas cylinders in the user guide, but for today's demonstration, we're going to be using gas cylinders from CalGas. we're going to be using 1000 ppm carbon monoxide. We're going to be using 25 ppm NO2 in a balance of air, and we're going to be using 25 ppm SO2 also in a balance of air. If you have any questions about which gas cylinders are suitable, which volumes, there's a really comprehensive description of gas cylinder purchasing in the user guide for the AQM65 as well as the AQS1. So just flick on over to the user guide and you can see there's a really comprehensive discussion of gas cylinders, concentrations, balances, all of that kind of thing. A quick refresher on adding a regulator to your cylinder. Make sure you wear safety goggles. I like to hold the regulator in my right hand. I like to hold the cylinder in my left hand. And I hold the regulator stable and I just twist the cylinder. I point the cylinder away from me. And after a couple of turns, you'll be able to see that the bottom gauge comes up and tells you how much gas is in that cylinder. So let's have one more go with the other gas cylinder. So that's regulator in the right hand, twist the cylinder with your left hand, and you should be able to see that the bottom gauge tells you how much gas is left. Be really careful with those gas connections, those gas lines. Aerocool supplies all of the gas fittings you need. We use swage lock 1/8 fittings with our regulators. It just needs to be finger tight, and then maybe 1/4 turn with a spanner. That's all you need to do. That'll be more than enough. Okay, and there's that bottom gauge again. If we look at the top gauge, you can see when you open up the cylinder regulator, there you go. You can see that the top gauge can go all the way over to 15 psi. Before you open up the regulator, you first have to make sure your gas connection to the back of the air cowl is secure. And again, just a couple of turns with the spanner is all you need to secure that connection. So we'll be connecting the carbon monoxide to port 1 and the NO2 cylinder to port 2 for our demonstration here. Just a quick summary, we have two gas cylinders, both connected to the back of the air cowl 1000, which is connected to the gas inlet on the AQM65. So back into the software now. We're now interested in delivering some span gas. Note that we are in normal operation, which means service mode has expired. That's fine. We'll be putting it back into service mode again, but in a slightly different way. So what we're going to do now is click the Start Calibration Run button. What that's going to do is it's going to allow us to define an external calibration run. We're going to tell the software which gases we're delivering and when we're going to deliver those gases. It's important to understand the software cannot control the air cowl 1000, but we can tell the software what we are delivering from the air cowl 1000. So let's give our calibration run a name. I'm just going to call it my calibration. Okay, and we're going to add our first calibration point. It's always a good idea to start with some zero gas. Currently the system is sampling from the air cowl 1000. Note that there are some parameters here, the gas, the cylinder concentration, which we need to define. Our first point, however, is defined as 0 for 10 minutes, which is absolutely fine. I don't think we need to change that by too much. We could change it maybe to 20, but 10 is perfectly fine. So that's going to be our first point. Our second point is going to be NO2. So we need to tell the software that we're going to be delivering NO2. So all we're going to do is select span port 2. We could select span port 1 or O3 calibrator, but in this particular case, we're going to be selecting span port 2. We tell the software which gas is connected to span port 2 because the software doesn't know. So previously we connected the NO2 cylinder to span port 2, so that's what we need to select. We must tell the software what cylinder concentration we have, and it was 25 ppm. And we need to tell the software what span concentration we plan to deliver. All of this information will later be used to calculate for us a new gain. Just a quick reminder that the software cannot control the AirCal 1000, but it's important for us to tell the software all of the various calibration parameters. So I'm going to let the NO2 gas run for 30 minutes, and that's going to be our defined calibration port. Just a reminder again where we get these cylinder concentrations from, the CO 1000 to NO2 25. Let's add another calibration point now. I like always to just deliver a little bit of zero air between my gas span points, so I'm going to just deliver 10 minutes of zero air and use that as my third calibration point. Let's have a look now at the entire run. Okay, we have 0 for 10 minutes, we have NO2 gas for 30, then 0 for 10, then we have our O3 calibrator for 30 minutes, 0, and then span port 1, which is our CO, and then finally some 0. All we need to do now is click start, and the software will put itself into service mode, and then it will then begin to expect these gases to be delivered at these particular points in time. So okay, calibration runs are used as a guide. You will need to manually control 0 and span. Good, we know that. Okay, so here we are now. The service label at the top tells us we have an external calibration run in progress running for 2 hours. Don't panic, the video is not going to last for 2 hours. We'll fast forward through much of it. We can see our defined calibration run here. The software thinks we're just delivering 0 air for now, so we're not so interested in calculating gains while we're doing that. But what we do need to do is set our NO2 calibration point manually on the AirCal 1000. So we go down to manual, we select our port, which I think is port 2. We have NO2 connected to port 2, and we've chosen a span point of 0.1 ppm, which means we need to enter in a dilution ratio of 250. Oop, overshot down. There we go. So we need to set that to 250. So that's set up. We click the down button and start. So now the AirCal 1000 is going to start delivering 0.1 ppm of NO2. Note that the mass flow controller reading in cc has gone nearly all the way up to full scale. That's nearly 50 cc. It shouldn't be 50 cc because we're giving a dilution ratio of 250, but every time we start a calibration point, the calibrator will always purge the gas line to clear out any air from the gas line. So expect it to shoot up to 50 for the first 30 seconds. And then after 30 seconds, it should drop back to a much lower level, which would calculate to a dilution ratio of 250. So if we just wait a couple of seconds, you should see that drop down. Should drop down to maybe 10 or 12, I think. There we are. So now the mass flow controller is delivering 10 cc. That's exactly what we would expect for a dilution ratio of 250. So back into the software now. Remember, the software doesn't know we've made that change. The software has no sense of what's going on. We can skip from the 0 point, which has 2 minutes 34 to go, straight into the next point, which is NO2. So now the software knows that the AQM is sampling NO2. That calibration point has been programmed in for 30 minutes. It'll run for 30 minutes automatically, and then it will automatically skip to the next point, which is 0. But if you see there's a little plus and a minus button, so we can always speed up the calibration point or lengthen the calibration point if we're not really ready. So rather than make you all wait for 30 minutes, we're just going to skip forward in time. Okay, here we are. Only 4 minutes to go. I'm not satisfied with the stability of the Ox module at this point. I'd like to wait a little bit more time, but we're running out of time. So I'm going to use the plus button to give myself a few more minutes for this calibration, just to allow the Ox module to become stable. So now I've added a few more minutes to that calibration port, so let's wait again. Okay, so this particular Ox module took a little bit longer to stabilize than we would expect. That's fine. We can see now over in the standard deviation that the standard deviation is 0.002, which is enough. That's perfectly stable. We can click recommend to recommend a new gain. The formula is just the same formula as you can see up there, used to calculate the gain. The software has recommended a gain of 0.683. If we're happy with that new gain, we can click apply, and the software will automatically click apply. So let's try that. Yeah, so I'm just pointing out here that the span gas concentration is 0.1, and that value is used to calculate the gain. Okay, are you sure you want to apply the new gain to Ox? Yes, I'm sure. It's really important to understand that we've applied this gain to the Ox channel. We do not apply the gain to the NO2 channel. Okay, so now that we've applied the NO2 gain, the next step is to apply gain to the ozone channel and also to calculate our A channel, our A parameter, which is associated with the NO2. So now we need to flick over to the ozone calibrator, connect that up, take the tubing off the AirCal 1000 and we put it onto the back of the AirCal of the 2B Tech, which has been delivering ozone and is now nice and stable. And it's really important to remember that when we go back to the T at the top, that we close the T off at the top of the AQM65, because there is a T already at the back of the ozone. So this is the configuration when delivering ozone, whether you have an AQM65 or whether you have an AQS1, same thing. Okay, so back into the software now. The software believes that we're sampling zero air. You can see there that we're nearly all the way into our 0 point. We can push skip, so we're now telling the software, just like we did with the NO2, we're telling the software that we're delivering 0.1 ppm ozone. Okay, that stabilized a little bit quicker than the NO2 did. That's really good. If you have a look at the standard deviation is about 0.001 ppm, which is fantastic. That's really nice and stable. All we need to do now is push the recommend button. Okay, the calculation recommends a gain of 0.773. Apply. Are you sure you want to apply the new gain to ozone? Okay. And excellent, it's done that. So now we've applied the gain to the ozone channel. We can just wait a couple of minutes to see the impact that's had on the ozone reading. It should come down and be stable at 0.1. Let's wait. Okay, great. Also, that will have had a very small impact on the calculated NO2 channel. The NO2 channel should be reading 0 now under these conditions, because it's not sampling any NO2, but you can see that it's reading a little bit higher, and this is now why we need to make an adjustment to this A parameter in the manual entry screen. There's a formula for calculating the new A parameter. You can find that in your user guide for the AQS1 or for the AQM65. It's very simple. It's just the Ox reading, equation 3 on screen here. It's the Ox reading divided by the O3 span concentration. So that's a really simple ratio, really easy to calculate that on a calculator. So that's the Ox reading divided by the ozone span concentration. So we can get both of those values from the screen here. You can see the Ox reading, you know what that is. You know that the ozone span concentration is 0.1. So that means that we can calculate a new A value based upon that equation. That's the Ox concentration divided by the ozone span concentration. So we enter that into the A parameter and click Save. And when we've done that, we can go back and we can have a look at the NO2 reading, and we should find that now the NO2 reading is close to 0. So having entered the new A value, we can go back to the calibration screen and have a look and see the impact of the new A value. So let's wait a couple of minutes looking at the NO2 graph to see what's going to happen. We can give ourselves a little bit more time just by clicking the plus button if we need to. There should be no change to the ozone reading as a result of that A change. There should be no change to the ox as a result of that A change, but here you can see now that the NO2, the calculated NO2, is now starting to come down and read exactly 0, which is exactly what we want to see when we aren't actually delivering any NO2 gas. So that's fantastic. Let's pop back over now to 0 air from our ozone calibration, because now we're finished with the Ox Ozone NO2 system. We're going to remove that cap off the T because we're now going to go back to delivering 0 air. So that was quite straightforward. That was a complete demonstration of how to calibrate the new Ox Ozone system. Just a reminder that when we go back to 0 air, that you remove the cap off the T, otherwise you'll get too much back pressure into the AQM. Sorry. Okay, so again, the software thinks that we're delivering 0 air, which we are. So the very next step, now that we've finished with the NO2 ozone system, I'll just do a quick demonstration of the CO span calibration, just so you can see how that's done. It's fairly straightforward. We just go back to our AirCal 1000. Now we're interested in delivering 10 ppm, which is a dilution ratio of 100. We know that our CO cylinder is connected to span port 1, so we first need to make sure that we select port 1. Then we need to define our dilution ratio. In this case, our dilution ratio is going to be 100, so we enter in 100. There we go, enter, and now we just go start. Just as with the NO2, we're expecting the mass flow controller CC to come up to about 25, but first, initially, it's going to go to full scale. This is just because it's purging those gas lines to make sure there's no residual air in the gas line. With the mass flow meter reading about 2,580 cc, a dilution ratio of 100 should mean that we're delivering approximately 26 cc from our port 1. So after the purge cycle has finished, that mass flow controller reading will drop back to around about 25 or 26 cc, giving us an exact dilution ratio of 100. The purge cycle lasts approximately, there you go, 30 seconds. Okay, so now we have a mass flow controller reading of about 26 cc, so that's giving us 100 times dilution on port 1. So that should be a result of 10 ppm of CO. So back into the software again. Now we need to make sure that we tell the software that we've moved on to the next point. We don't want to wait for the 0, so we just click skip. And now the software knows that we're now delivering CO. Just a reminder again, the software does not control the AirCal 1000, nor does the software receive any information from the AirCal 1000, so you have to do all of this manually. Okay, so we've skipped through about 15 minutes through the CO calibration. It's come up really quickly. CO often calibrates quite fast. It's come up a little bit further than it needs to. You can see the average reading is about 13. So we recommend a gain. Obviously the gain is going to be lower than the current gain. Remember, it's just applying this formula. The new gain is equal to the current gain times the span gas concentration. Do you want to apply the new gain? I do. And now the new gain has been applied. Okay, so we can just wait a few minutes. There we go. So after applying that new gain, we can see that the reading has come right the way down to 10 ppm, which is exactly what we want. So that's perfect. So really simple to calibrate the CO channel in this case. Okay, so it's always a good idea to just complete any span gas calibration you do with zero air. So we're just going to head back to our AirCal 1000. We can stop that CO span point now, go through our menu, go back into manual, and just select port 0, which is our zero air. So back into the software again, and the final point is to tell the software that we've completed the CO calibration. So we can now just push the skip button, which informs the software that we're now delivering zero air. So the zero air point is programmed for 10 minutes. We won't wait the entire 10 minutes. Let's skip ahead and see what happens after we've finished delivering zero air. Okay, so the CO response has come all the way down. That's exactly what we want to see. It's reading almost zero. So that was a really good calibration of the CO module. If we fast forward even further, right towards the very end of the 0 point, we can have a look and see what happens as the calibration run comes to an end. Okay, so the calibration now only has about 6 seconds left. After the calibration run expires, it'll go back into normal sampling mode. That signals the end of the guided calibration. Up in the top left-hand corner, you can see normal operation. That now means that all of the data is tagged as normal measurement data. Now we can detach the zero air inlet from the AQM. Remember to put back the dust cap, and also remember to safely shut down your AirCal 1000 and safely remove the gas connections from the cylinders.
Okay, so we've finished with the ozone calibration, the NO2 calibration, and the CO calibration. The next step would be to exchange the CO cylinder or the NO2 cylinder for the SO2 cylinder, and then we would go ahead and complete the calibration for the SO2. So I hope that illustrates the procedure for calibrating especially ozone, NO2. Remember, the order is very important. It's really crucial that you get the NO2 Ox module calibrated first, followed by the ozone and everything else. So I hope that was informative, and good luck.